Your MCP tools need to handle everything from simple greetings to complex nested data structures, but writing separate code for each case shouldn't be required. We'll see how FastMCP's call tool method cleanly handles both flat arguments and deeply nested configurations in the same call, with automatic type conversion for the results. You'll work with primitive values, lists, dictionaries, and even custom objects, all through a single consistent interface.
Async with client. Hash simple arguments. Result equals await client, call tool, greet. Name, world. Hash complex arguments. Result equals await client, call tool, process data. Config, format, JSON, validate, true. Items, 1, 2, 3, 4, 5. Metadata, source, API, version, 1.
This demonstrates the remote procedure call pattern through a declarative client interface. FastMCP abstracts tool execution into simple method calls, where complex operations become single-line invocations with automatic serialization and transport handling. The distinctive aspect is how it bridges the gap between local Python code and distributed systems, making remote calls feel like native function execution. The pattern works by encapsulating all transport complexity within the client context manager. You pass structured arguments as native Python dictionaries, while the framework handles protocol negotiation, error translation, and result hydration behind the scenes. This separation of concerns lets you focus on business logic rather than RPC mechanics, with the client managing everything from connection pooling to schema validation. This approach matters because it eliminates the traditional friction of remote procedure calls. Instead of writing custom API wrappers or dealing with raw HTTP requests, you interact with remote tools using Python's native async await syntax. The pattern shines in microservice architectures, AI tool integration, or any scenario where you need to treat distributed components as local dependencies, with the trade-off being a slight abstraction overhead for the simplicity gained. Let's break it down line by line.
Async with client.
Context manager pattern for async client connections. The async with block handles proper resource cleanup when the operation completes, preventing connection leaks. This is the standard pattern for managing async client lifecycles in FastMCP.
Hash simple arguments. Result equals await client, call tool, greet. Name, world.
This demonstrates calling an AI tool with simple arguments. The call tool method takes the tool name and a dictionary of parameters, here passing a single key value pair for the greeting. This pattern mirrors how AI models invoke tools with structured input.
Hash complex arguments. Result equals await client, call tool, process data.
This demonstrates passing structured arguments to AI callable tools. The dictionary format handles complex nested data, enabling tools to accept configurations, arrays, and metadata in a single call. This pattern mirrors real-world API usage, where tools often require hierarchical input.
Config, format, JSON, validate, true.
This nested dictionary defines processing configuration. The format, JSON, key specifies JSON output structure, while validate, true, enforces schema validation on the input data, preventing malformed payloads from being processed. This pattern centralizes processing rules in a single, versionable configuration object.
Items, 1, 2, 3, 4, 5.
This passes a list of integers as the items parameter to the process data tool. The array structure enables batch processing of multiple data points in a single API call, improving efficiency over individual requests.
Metadata, source, API, version, 1.
This embeds tool-specific metadata as a nested dictionary, provides versioning and source tracking for the operation, enabling better debugging and audit trails when processing data through the tool. This closing parenthesis and brace terminates the nested dictionary structure, finalizing the complex argument payload for the process data tool call. It ensures all configuration, data items, and metadata are properly encapsulated in a single structured argument before being sent to the server. FastMCP Tool Transformation Pattern. The tool transformation system lets you reshape server capabilities at the client level, where argument defaults become invisible constraints and renamed tools create domain-specific abstractions. Transformations apply during initialization, so changes won't affect already connected clients until reconnection. This pattern enables progressive disclosure of complexity while maintaining a single server implementation.
The client that renames a tool becomes its only true author.